Okay, our next couple lessons are going to be focused on specific equations of lines. Okay, so the method that we learned by making a table that we learned in 6.2, that's a method that can really work for anything, which is really pretty cool. It can work for any kind of graph. You can make any graph by just making a table of values. Now, for lines, it's easy. You really only need about 2 or 3 points. For other types of graphs, it can be a little trickier. You may need 3, 4, 5, 6, 7, 8, 9, 10, or more points. But you can pretty much make any graph by making just a bunch of points and then connecting them and trying to figure out what shape they look like and having a little bit of knowledge of what that shape should be. However, there are very specific formats for equations of straight lines that we can use techniques to graph very quickly. One is called slope-intercept form. Okay, slope-intercept form is when an equation is in the form y equals. Okay, so the y is all by itself. There should be no coefficient next to y, nothing. It should just be y equals. So some examples would be y equals 1/2 x plus 3, or y equals 3x minus 1, or even y equals 2x. Even though we don't have a plus b there, we'll figure out kind of what to do with that. It's called slope-intercept form for a very creative reason, very creative indeed. It's because whatever number is being multiplied by x, so is in the spot for m, that is what we call the slope of the line. And b, whatever is in b, is the y-intercept of the line. So it's called slope-intercept form because it gives you the slope and the y-intercept. Yes, someone was clearly trying very, very hard to come up with a very creative name when they thought of that one. Before we can figure out how to graph, we need to know what slope is. Slope, which we often represent by the letter m, don't ask me why. Some French guy made it up or something, probably. I don't know. Ask me in class maybe and I can figure it out for you. Or, you know what, better yet, use our good friend Google and figure it out on your own. Haha. Slope is defined a couple different ways. It's defined as, my favorite definition is the change in y over the change in x. Okay, that's not a triangle, that's the Greek letter delta, delta meaning change. Another way to look at it is a lot of people use the phrase rise over run. Okay, so how far the graph moves up and down versus how much it's going right and left from point to point. And those are pretty much your two popular definitions. Okay, so if I gave you 2 points and put them on a graph, you should be able to figure out the slope. Okay, so let's say I wanted to know the slope between those 2 points. What I would do is I would count, well, how much am I changing in the y and the x direction? I'm changing 1, 2, 3, 4 in my y direction, and I'm changing 3 in my x direction. So the slope between those 2 points would be 4 over 3, 4/3. Better yet, I could give you 2 points. And I'm sorry, I could give you 2 ordered pairs, -1, 2, and 3, 1. And you should be able to tell me what the slope between those 2 points is. Now, there's a couple different ways you could do it. Obviously, I think the easiest, or most, I don't know, maybe not easiest, but the way you'd probably think to do it is to plot both the points. So there's my point 3, 1. There's -1, 2. Connect them with a line. And then just check. Well, I changed by 1 in my y direction and 1, 2, 3, 4 in my x direction. So the slope is 1 over 4. The other option you have, we do have a little slope formula. And we'll talk about this a little bit more when we're actually creating lines. If you want to figure out the change between 2 points, what you do is you simply subtract your y values and subtract your x values. The key is you got to make sure you start and end with the same point. So I'm going to start with this one, 2 minus 1. See, this is one of my y values, and I'm subtracting the other one, over -1 minus 3. Oh, good, and I caught myself on a mistake I just made a second ago that I'm going to go back and fix. So I get 1 over negative 4. Just noticed the mistake I made. We do have positive slopes and negative slopes. Okay, so up and right are positive directions. Okay, down and left are negative directions. Okay, so you could look at this particular slope, like this first one here, in 2 different ways. You could look at it as up 4 and right 3, so that'd be positive 4 over positive 3. Or, if you wanted to start from this point, you could look at it as down 4 and left 3. But those are both negative, so you'd get negative 4 over negative 3, which would still be positive 4/3. This one's a little bit different. It's sloped the other way. Okay, so this one is either down and right, negative over positive, or up and left, positive over negative. Either way, you should get a negative slope there. So the slope of the second one is negative 1/4. If you want an easier way to remember it, all positive slopes are going to be up and right. All negative slopes are going to be down to the right. Okay, I like to think of it as, if you remember those old school Mario games, you used to have like the character would always just be kind of on this side and would always be forward, was always to the right. So if Mario would be walking uphill, it's positive. If Mario would be walking downhill, it's negative. It's kind of a fun way to remember it. So back to, we're going to get more into slope in a couple lessons when we're figuring out how to actually write some equations based on some given information. But that's enough on slope for now. How to graph something in slope-intercept form, it's 2 steps. You need to graph the y-intercept first, and then you need to use the slope to make more points. The key is you have to have a point on your graph first in order to use the slope. Okay, so you have to have a specific point to start from, because the slope doesn't tell you where something is, it's telling you how to change from one point to the next. Okay, so let me give you guys 2 examples. So this first one, 2/3 x plus 4, my slope is 2/3 and my y-intercept is 4. I need to graph my y-intercept first, so that goes 4 on the y-axis. Slope of 2/3, that means I'm going up 2 and right 3 to create new points, so I could do that as many times as I wanted. And remembering what we talked about for slope on the last page, though, I could also do 2 negative motions, and that would still create a positive slope, so I could do negative 2 and negative 3. Down 2 and left 3. And I could do that as many times as I wanted. I often like to do it as many times as I can that'll fit on the graph, because it makes it easier when I'm drawing my line. I'm not good at drawing lines freehanded, and I suggest you use a straight edge, but that was actually pretty good for me. So this next one, it's just a little bit different. Okay, the difference here is that our slope is negative. Okay, so it should be slanted the other way, and our y-intercept is negative 2, although that shouldn't make too much of a difference. I need to graph my y-intercept first. Okay, I've got that one. Now I need to go either down 3, a negative motion, and then a positive, so down and right or up and left. I'm going to go down 3 and right 2. Or I could go up 3 and left 2. And again, just make sure you're putting arrows on the end of those lines to signify that the solutions keep going. Okay, these last 2 are both tricky for various reasons. I want you to try this one on your own, but I want you to notice something first. We have to make a change. This is not currently in slope-intercept form, is it? Right? Because the y is supposed to be by itself. So think back to when we did literal equations. How would you solve that equation for y? Pause and try it. Okay, hopefully what you figured out is that you just need to add 2x to both sides, and now you get y equals 2x minus 3. Okay, what I want you to do is try graphing both these next two lines. I realize they're a little bit tricky, but see if you can figure it out. Pause and then come back. Okay, here our y-intercept is negative 3, and our slope is 2. Let's deal with plotting the y-intercept first. That's right here. Now the question is, how do we deal with a slope of 2? Because we're used to having fractions that tell us the change in y over the change in x. Easiest thing to do is make that into a fraction of 2 over 1. So now we know that our y's are going to change by 2 and our x's are going to change by 1. It's a positive slope. Up 2 over 1. Up 2 over 1. Or again, down and left works too for positive slopes. Connect them with a line, put an arrow on the end. This one was a little bit tricky, even trickier than the last one. Our slope is negative 3, which we know now we're going to change to negative 3 over 1. And our y-intercept, well, think about what we could add to the end that wouldn't change anything. It would be 0. So our y-intercept is 0. Our y-intercept is the origin. And again, we need to go down and right for a negative slope, or up and left. Connect with a line, arrows on the end. So hopefully you picked up on those tricky ones. Again, we're going to talk more about slope as we go throughout this unit, but just wanted to get as much slope stuff in there as possible early. Biggest thing is knowing how to graph in slope-intercept form, which hopefully you learned a lot about. That's it.